We're really excited to offer our first webinar today with a new partner that we're very excited about, 9.Connects. Today is all about PCB, and what we're really excited about today specifically is partnering with 9.Connects because they're experts in this area. As SolidWorks continues to grow and offer new products, that of course offers new avenues for us to help our customers, which is always good. And we reached out to 9.Connects because long before SolidWorks even dreamed of getting into the PCB business, 9.Connects was already serving many, many companies for years on how to do best-in-class design in this area and leverage these kinds of tools. So with that said, I'd like to introduce 9.Connects and some of that team, Christopher Che, Paul Tubman, and Tom Cassidy. And Paul, if you don't mind, why don't you get us started? Thank you.
All right, very good. Thank you very much. Okay, hopefully everybody can see my screen at this point. I'm gonna switch off the cam here, and I think everybody should be able to see the banner here. My name is Paul Taubman with the 9.Connects. Also with me here today is Tom Cassidy. So you are in the right place if you are here for our webinar on One Step Beyond. Basically what we want to talk about here is the use of step files, but more importantly, if we can get beyond the use of them. If you're familiar with step files, they're wonderful things that we've used for almost really the past decade to communicate between MCAD and the ECAD world. But there's better things out there, and that's what we want to show and present to you here today. So before we get started and go any further here, here are our mugs. So you can see me here on the left, and then Tom here on the right. And the reason what we want to do is just kind of let you know that even though we come from the ECAD side of things, both of us have quite a bit of experience on the MCAD and just on the mechanical side as well. Tom is actually just as well versed in SolidWorks CAD as he is in really with the SolidWorks PCB tools. I myself, before I came into 9.Connects, had spent quite a bit of time on test floors. I was a test integration engineer, and so dealing with both the electrical side and the mechanical side was pretty much my day-to-day job when I was doing that type of work. So both of us are very familiar with the mechanical side, so this is not going to be a one-sided type of thing. We want to show you how you can push to and from both sides here. What we also want to mention here is that both of us are actually broadcasting from different cities, so we're not in the same room. We're going to be using different computers with different software, and just to kind of make it even more interesting here. So it's not just me talking to you and pushing everything from a single laptop. Okay. Just to let you know, we will definitely have a questions period at the end, so please submit those at any time, by the way, because we also have Christopher Che, who's the owner of 9.Connects, on here. And he's got quite a bit of knowledge as well, so he might be able to answer a question or two. So feel free to use that questions panel, and if he doesn't get to it, we'll certainly take a look at that question at the end here. So let's take a step back for a moment. There's probably one or two reasons why you're here, because either you're a mechanical engineer and you're just tired of fighting with the electrical folks because they're sending you stuff that's not easy to work with, or you actually are interested in SolidWorks PCB. So if you're here for either one of those reasons, hopefully you'll get some really great insight as to what you can do with this particular tool. And even if you're not going to be the one using SolidWorks PCB, hopefully after what you see in this tool here, it gives you an opportunity to go talk to the electrical side of things to show them that collaboration can be much easier than what it might be right now in your workflow. What are our objectives here today? Let's talk about the limitation of step files, give you some examples there. Then we want to show you what this path is between SolidWorks PCB and SolidWorks CAD. So there is a path that we want to understand. I also want to do an ultra quick understanding of ECAD library structures because it kind of explains why they set things up the way they did. Well, and then after that, and that's all you're going to see with the PowerPoint slides, we're going to show you an example of an ECAD initiated design to MCAD, and then we'll show an example of an MCAD design that's initiated, MCAD initiated design to the ECAD side, again, for questions and answers afterwards there. Okay, step files. One of the great things about them is they truly are a universal language. I know that they were primarily set up as a universal language for really the mechanical folks, but the ECAD folks about a decade ago realized that we could bring it in too, and said, hey, this is really great, and it's now allowed for collaboration, which we didn't have before. And just to give an example, there was a place that I worked at, and I was assigned as the person who had to draw the schematics, which is the conceptual design, and they assigned me a printed circuit board individual and a mechanical individual. Both these guys had more experience in my life on Earth, at that particular time. They're very well advanced in their knowledge, worked with them, and we still had to do a respin. And why was that? Because we had no way of collaborating between the two tools. One of them was using a PCB tool, the other one was using an MCAD tool, and they were effectively having to rewrite this stuff, and they weren't really able to push anything back and forth to each other. So there was a little bit of a dimensional incorrection there, and that's why we had to do a second respin. So hopefully you're a little bit beyond that, but that's what step files allowed us to finally do, is to do some collaboration between the MCAD and the ECAD worlds. This just shows you basically what we have to do with steps. However, we usually have to do some type of export out of the tool that we're using, whether it's on the ECAD side or on the MCAD side. Got to export it out because no one really ever works in step, right? We can import those things in, but there are native formats to each one of the tools that we're using, because step is great and it's universal, but it's not efficient. So what do we have to do? We got to export it out. We got to put it someplace that someone on the other side of this ECAD MCAD chasm can make use of, and then they've got to import it in, and we got to communicate this through emails. And of course, a lot of times these step files are so big that you can't necessarily send them to each other. So if you don't have a shared directory, you got to come up with a Dropbox, or you got to come up with some FTP site. And this is how we go back and forth. So it's really administratively intensive. So what are the disadvantages? Well, the importing, exporting hassles, as we just saw on the last screen. And not just that, it really comes down to the fact that in SolidWorks CAD, the PCB comes in as a bunch of assemblies. And we'll show you here and demonstrate that here in just a moment. And vice versa, in SolidWorks PCB, the component comes in as one blob. It's almost as if you dropped a bunch of things into cement, the cement hardened, and now that's it. You can't get that stuff out of there because it's just one big representation. And at the end of the day, there's really no intelligence to it anyways. It's just really more for aesthetic purposes. And that's good for fit checks, but we want to do something beyond fit checks in many cases. So I'm going to escape out of our PowerPoint presentation for just a moment, and I'm going to show you our screens here. So what you're seeing on the screen here, just before we continue, is that here's SolidWorks PCB. So this is the SolidWorks PCB tool. And on the right side over here is Tom Cassidy's SolidWorks CAD tool. So you're seeing my screen over here in San Diego, and we're also using a Skype screen here so we can bring in Tom's screen as well. So what I'm going to do is I'm going to enlarge Tom's screen over here so he can show you what happens when he brings in a step file.
Okay, hello everyone. Thank you, Paul. As he mentioned, basically what you're seeing here is a step file that was exported from ECAD and brought into SolidWorks. And as you see, it's not too bad. It looks, you can see everything you need to see. However, if you look over here, you basically find out that all of the parts are individual step files as well. So that greatly limits your ability to do anything with them within SolidWorks. You could convert them if you wanted to and go through some other things, but for the most part, what you see is what you get. And like Paul said, there's really not a whole lot of intelligence. So you can't move things very easily. You can unlock them and go back and unfloat them and whatnot, but there's really just not much you can do with it per se.
Thank you. And what I'm going to do over here is I'll show you on the PCB side here what happens when we bring in basically the same file. So in the this is SolidWorks PCB, by the way. And by the way, as a side note, I know there's a lot of tools and products from SolidWorks. Some of them are add-ons to SolidWorks CAD, some of their own separate programs. I want to make it clear that SolidWorks PCB is a separate program. It's not an add-on to SolidWorks CAD. So just be aware of that here. So what I'm going to do over here is I've actually got what they call the printed circuit board layout editor up and running. So this is a brand new board. That's what you see with the dashed line over here. And if I wanted to do something with that step file, I can bring it in. But quite frankly, there's not a whole lot I can do with it. As a matter of fact, it's not even imported in. It's actually treated as an object over here. So if I go over here, for example, and I bring it in, and I'm going to bring this file here. So there it is. So it's treating it as an object, okay? And I'm going to press OK. Alrighty. And then once it's bringing it in, because it's got to render it here, then we can take a look and see what we have, what we can do with it. Okay. So there it is, and you notice it's just a block. Okay. And I'm going to cancel this because I'm not bringing anything else in. So it doesn't really show anything in the 2D mode. So by the way, in the print circuit board layout, we tend to work in the 2D mode here. So there's nothing to even look at on the 2D mode. It's all just simply a 3D representation here. So if I hit my 3 key here and I bring it in, there it is. But again, very similar to what you saw on the SolidWorks CAD side, there's nothing I can do with this. I can't route this. I can't move anything over here. There's no intelligence. It has no idea that these are capacitors, or this is a battery holder, or these are connectors. So from an enclosure point of view, if this was an enclosure, I could bring it in and I could do a fit check, and that works great. But if there's some electronics that are being sent from the MCAD to the ECAD side in the step format, it really doesn't help me unless it's like a component itself. And even then, if it was brought in as a component, there's other limitations that would require me to do a lot of work to make it useful. So there you go with the step files. They're great, but they've got a lot of limitations to it. So let's jump back over here to our PowerPoint presentation over here. So is there a better way? That's really the bigger question here, and there is. So what SolidWorks came up with is that using the traditional SolidWorks CAD package, which you're probably familiar with, they also created SolidWorks PCB. Okay, so they have this PCB tool as well. But in addition to that, they also have this thing called the SolidWorks PCB Services. And this is used to allow these things to communicate with each other in pretty much near real time. And the reason they've got to have this, and I'll talk about this here in a moment, is just because the paradigm, I know it's an overused word, but it's really the paradigm of the ECAD world and the paradigm of the MCAD world are very, very different from each other. Now you can see, and again, I want to emphasize this, that I'm in San Diego presenting. We have our server in Texas, and we've got Tom here in Houston. We're going to show you here in a few minutes that we can push back and forth between SolidWorks PCB into the SolidWorks PCB Services and then into SolidWorks CAD. And by the way, I should make mention of this. This is not any extra cost for the SolidWorks PCB Services. It comes with SolidWorks PCB. Now, the one thing I need to mention here is that ECAD actually does own the project. And you may say, well, that's not fair. How come they get to own it? There's some reasons for that. I do want to mention, though, that MCAD has 5 different things that they can change in the project once it gets passed over to them. The first one is the board itself. The second one are these things called barriers. Okay, so this is something recently added in to it. So these barriers so that you can prevent certain components from being placed down on the ECAD side. You can also place down holes, board holes, mounting holes, and lastly, you can move around components. And so all of these things are very, very important. Now, why is that? How come we can't start things on the MCAD side, or why does the project actually have to initiate on the ECAD side? The reason it has to do is because of the different ways or the different flows that we have when we are doing design. Now, MCAD is really, it's a very pleasing and very straightforward methodology for creating things. When you create a part, you're simultaneously not only creating a part for the project, you're also creating a part for a library. And so as you take these parts, you work from the bottom up and you create assemblies, but you can use these parts again very easily in other projects. Now, we can do the same thing in ECAD, but we have 2 steps that we must follow. The first one is something that's called Schematic Capture. Okay? And Schematic Capture is a conceptual concept. It is dimensionless. We cannot, what we really can't do is anything really physical in it. It's not supposed to be physical. It is just dimensionless representations. And the key thing we're supposed to get out of Schematic Capture is how we are supposed to connect all of these pins on these components to each other. That's really what we get from that. And that's called a net list. And we push that out to the PCB. Now, in order for the Schematic Capture to work, we actually have a library. It's called a symbol library. And you can see an example of a resistor over here. So this is a variable resistor. It's actually one you can actually adjust. So it's got 3 pins to it. But this isn't what it really looks like in real life. This is just a schematic or a symbolic representation of it. So we have a library full of symbols and representations. This information, the Schematic Capture, gets pushed over to the PCB layout. But we can't use the symbol library in the PCB layout. We have to have another library that's called the footprint library. And what SolidWorks PCB can do is it can take in 3D representations, like step files, okay, of at least these components over here, so that you can represent that component not only as a 2D footprint, which is where we tend to do most of our work, we can also represent it in the 3-dimensional space as well, so we can see what it looks like in 3D. And because we can represent this in 3D, this footprint over here in the 3D space over here, now we have the ability to push this information over to the MCAD side, have the MCAD side make changes to that, like move it around, push it back, and we know that the push or whatever got manipulated in terms of the components have been moved around, and we can see that, and it still keeps its links to not only the Schematic Capture net list, but it keeps its links also to the library as well. That's why, unfortunately, as much as we want a lot of things to start in the MCAD side, like components, if you take a component and you push it to the ECAD side, there's no representation as to where it was in the schematic, and there's no representation here on the layout as to its relationship to the footprint library. So that's why things have to start in the ECAD, because we need that foundation in order to go from the ECAD side to the MCAD side. And this here I just put together very quickly. It's a visual representation. Here's a schematic. Okay, again, conceptual concept. We don't have any type of dimension to it. We go from that, and then we push it over here into our layout editor. Here's our 2D version of it. Here's the 3D version of it. So in 3D, in SolidWorks PCB, it's really just more for visual understanding by the user. But all of our work we tend to do in the 2D area. But because we have this 3D, we can push it to the MCAD side. We can move things around, and as a result, we can have this collaboration back and forth between the MCAD side and the PCB side. So that's what I've got for PowerPoint slides for the moment here. Let's demonstrate these concepts in the tools themselves. So what I'm going to do here is I've got this project up that's called the Rangefinder project. Here's one of its schematic. It can have multiple schematics. But more importantly, what I want to show you over here is here's the board. So this is the board. We don't have any routing on this board, and this is a really, really important concept to understand, and regardless of what type of collaboration you do, there's really actually two major steps in a PCB design when you're trying to do the layout. The first one is actually the placement itself. The second one is the routing. And the reason we don't want to move things around when we start the routing is because it doesn't simply rubber band. If there's small parts and you can move them, there is some rubber banding capabilities where the traces can move around and stretch. But in high-speed design or in designs that got literally hundreds of pins, you got an FPGA or a microprocessor or a digital signal processor on there, and if you had those all routed in and you were asked to move that even a quarter of an inch, you've just added 2 weeks to the design time, because all that routing has to be torn up, it's got to be redrawn in, and more importantly, if it's a high-speed design, it has to be match length tuned, meaning like they actually have to measure out all of the lengths to make sure that the signal propagations are going to meet timing requirements. So this is why it's really important to have something like this so that you can get all of that placement done out of the way, so when the routing is being done, there's none of that second guessing as to whether or not something's going to get moved later on. So this is what we're going to start off with. I'm going to hit the 2 key so you can, or pardon me, the 3 key here so you can see it. So there is the 3-dimensional representation of this particular board. And again, I can move things around over here, at least from a placement point of view, but most of our work is done in the 2D. Now, this is connected into the PCB services. So what I'm going to do here is I'm going to click on the SolidWorks PCB Collaboration tab that we have here. And both our tool, I probably want to say our tool, I'm talking about SolidWorks PCB and SolidWorks CAD, both have this SolidWorks PCB Collaboration capability. So I'm going to push this over and just say, hey, this is my initial release for MCAD review. So I'm going to post that over here. And now you can see it's now communicating between my machine here in San Diego, and it's now communicating with the server that's sitting in Austin, Texas. Okay, so it'll take a moment here, so a little bit of latency, but nevertheless, it'll be done here in just a moment, and I'll know because this has now been changed over here, and it's locked into this conversation. So the conversation shows that. I'm going to minimize my screen over here, and then we'll bring up Tom's screen so we can get a better look at what may have happened, what has happened. So let's bring that up over here. All right, so there's Tom's screen, and he's got SolidWorks CAD up.
Okay, thank you, Paul. So as Paul mentioned, ECAD owns the project. So he started a project, he created the repository on the server, and he did the initial push. It's now up to me to pull it back in. So basically what I have to do, if you see over here on the right, I've got 2 buttons. One's a new board assembly, one's a pull. We're going to go ahead and just do a pull since it already exists. I'm already attached to the server. So I press that button. It's going to start talking to the server. And these are the available projects I have. And I believe...
Very top one. Very top one.
Top one, okay.
Yep. There you go.
Okay, so this is the project. Let me say yes. It's going to start talking to the server, and it'll come back and ask me for a place to store locally. Since this is going to be a SolidWorks project, it needs to have local files as well. So I've just got a place here I'm going to store locally. It's going to start thinking things through. Bit of a delay, but it's working on it.
So keep in mind what this is doing is that the information that's being pulled in, it's taking everything that was sent in from the ECAD side into the services, but now it's got to translate some of that stuff over. So yes, some of those things are going to still come in as step files, but there's also some other translation things, because there's things what we call primitives. And in Altium Designer, there's a number of different what we call copper primitives, and those have to be evaluated. In some cases, they are being pulled in, and in other cases, they're not. So that's another element of it that we have to, that it has to take into consideration.
Okay, I'm not quite so sure why it's taking so long. It usually doesn't go this bad, but it's getting there. Here we go. Okay, as you can see, it's brought in the project. So now I look over here on the messages. You can see the message originally from Paul, and this is the release. Just one thing to emphasize is this is an actual SolidWorks project. So if you go over here, you can see all the parts are actual parts. They're part files, they're not steps, so that gives you the full range of ability to mess with them. You can open them as a part and whatnot. So we have all of the abilities of SolidWorks parts to mess with. And I think the next step is for me to say, okay, I like this, but I don't like where this chip is. So I'm going to move it up closer to the switch for whatever reason, and probably not a normal thing, but you know, within the enclosure, perhaps I just didn't have space for that. So I'm going to say, this is, I want to move this chip. I'm going to go push that back to the ECAD side. So as Paul did originally, I'm going to go up and press the push button. I'm going to type in a message. So that should go to Paul. And then I'm going to post that. But Paul, do you want to bring up a split screen so we can see what happens?
Yeah, certainly. So I'm going to split the screen over here. So after he presses the button, now that the MCAD and ECAD are now talking to the same project over here, if he actually pushes it in, I'm going to be notified of it here, and you'll see that pop up in the SolidWorks Collaboration panel here in just a moment. And there it is. Okay, so I'm going to now extend out my screen again so you can see this here. Let's close this one up for a moment. Okay, so I'm not going to discard it. I want to view the changes here. So let's take a look at what he's done. And there can be multiple changes, by the way, just for our purposes here. We've only pushed one change, but there can be multiple changes. Things like, for example, mounting holes that got moved, the board being changed, the barriers being added, or the components being moved about here. So if I want to see what they've done, I can easily just click on it here and I'll get a graphical representation, because this board it's not that bad. It's actually got a lot of real estate to it. But if I had a board that was heavily congested, a lot of parts to it, it may not be obvious as to where U1 is. So if I just click on it over here, hopefully you'll see that on my screen here, there was a shadow coming up of where it's being proposed to be placed. Okay? And if I missed it, I can always click again on one of the other columns here and it'll just repeat it over again. A very useful thing to do. If I want to see it in the 3D, I can do that as well. So if I click on this, I can see what's going on there. Now, this is a reason why it's so important to have really good models. Because one of the things I mentioned earlier when we were pushing stuff over is one of the things that wasn't getting pushed over was the copper. So what the MCAD side didn't see was where the copper was in this. And the other thing is that this is not necessarily the best of models. It's a model, and it's got some dimensions to it, but it doesn't have any of the gull wings to it. So what Tom, or in this case the MCAD person, could have thought of is that this is what they call a BGA, meaning the ball grids are actually underneath it. We didn't realize that, no, this actually was just kind of a sloppy model. I can't use this because obviously this is going to have some shorts to it, but what I can do over here is I'm going to go back into the 2D mode. I could move it in 3D, but normally we move these things here in the 2D. Is that, well, first and foremost, can I accept this? In this case, I'm going to say no. Okay, so I'm not going to, it's weird because I'm going to say I'm not going to accept this here, but I'll accept this as a change, but I'm not going to accept the change itself, but recognize the fact that this has now been brought in. So at this point in time, I want to inform Tom, or in this case the MCAD side, that I can't accept this because it's going to cause collisions with this switch 1 over here. So, and right now, as it speaks, I have something different than what he has. So anytime something gets initiated, we kind of got to go full circle to make sure everybody's in sync with each other. So at this point here, I'm now going to push this back and say sorry. Okay, SW1 and E1 are too close.
And you want to go split screen before you send?
Yeah, I'll do that. Thank you. And so I'm going to split screen this so you can see in real time that he's going to get that message once I press post. Actually, there'll be a little bit of a delay, but you'll see it there. There we go. So I'm going to press that now. And then in a moment here, you'll see that Tom's going to get a message. Okay. So that's been sent here, and now on his side, there's the message, and I'll press it in. I'll expand him out.
Okay, so as Paul mentioned, I received a message saying that sorry, switch 1 and U1 are too close. So I would like to obviously see what's going on, so I'll view changes. And in a very similar way that would happen on the ECAD side, I'll be able to view what happened in animation. So basically what he is saying is this change here has to be undone. So it's actually a change that's unchanging the change. So just like Paul said, I can click on it and I can see animations of what he wants to be done. And since he seemed pretty adamant about it, I'm going to go ahead and say, okay, I'll live with that. I will hit the accept button and then I'll accept it. And what this will now do is synchronize the two projects again. Basically, it's synchronizing my local copy with what's on the server. And once I've done that, you can see everything is done. This chip is back where it was. And I now have the same representation that Paul has. And once again, need to emphasize that ECAD owns the project, so I need to make sure anything I do he knows about and anything he does I know about, but he is the one that is in charge.
Okay. All right, well, thank you. I think at this point, hopefully you got an idea of what this particular scenario looks like here. And as a side note, again, you can push these things back and forth all day long, and it doesn't have to be reserved to just one push at a time. There can be multiple things that are going on there. So as long as there's a communication that's going on there, you'll get that all hashed out and it'll work out just fine. The second thing that we want to show you over here is in situations, and this happens quite often, where somebody's already started the work on the MCAD side. And that's perfectly fine. So there is a way to actually initiate a board on the MCAD side and get it onto the ECAD side over here. So the one thing that has to be understood though is because as we mentioned before, the project has to start on the ECAD side for reasons explained. So what I've already done over here is I've been informed that Tom's already started a board that he wants to use. And what I've done over here is that even though I have not even started my design over on my side yet, I initiated a project already. So I did this project PCB, and I've already created the PCB dock here. So let me zoom this out. So this is the default. Anytime we start off with a printed circuit board with nothing on it, it's basically a 4" by 4" board, and from there we do our artwork and bring things in. But in this case, again, he's already got the board that he wants to have pushed in. So this project is now sitting in PCB Services. And so what Tom can do is he can now push this information from MCAD into ECAD. So Tom, I'll give you the, I'll just expand out your screen here for just a moment.
Okay, so as Paul mentioned, he set up the project and it is on our server and he gave me that information. So in the interest of time, I went ahead and edited it in, but you can see up here, the project is, this project name is the name on the server. And basically what I want to do is say, okay, this is the board I want to use and I want to push this in. So once again, I'll hit the push button and say this is the first board and I will post that. And Paul, do you want to split screen to see?
Yep, so we can do that, show everybody here. So let's push this over here. Okay, So let me bring up my collaboration panel so that we can see it there.
And then while Paul's doing that, just to let you know, this is a very simple board shape for demonstration, but you could have, you know, very complicated shapes that are fairly easy to draw in MCAD, but a lot harder to draw in ECAD. So that's another reason you might want to do your initial design in SolidWorks. Just it has better tools for drawing weird shapes. Okay, so I'm going to post, and once it gets posted.
Just as a side note too, one of the things that it's a really big difference that you find between the MCAD and the ECAD side of things. The MCAD side does a really wonderful job with this concept called relations, whereas on the ECAD side, we are very, very grid-based. And because you have a lot more control over the relations, you can come up with some really unusual and cool-looking boards. And by the way, the manufacturers can put out boards that are beyond square and rectangular too. So if there's curved boards or boards that have got to do some, you know, interesting turns and twists because they've got to fit into some design that's anything but square or rectangular, it's much easier to do it on the MCAD side than it is on the ECAD side, but we can certainly pull it in. So here you can see the notification has come up. I'm going to go full screen at this point, and let's view the changes. So we've now got the board outlined, so I'll click on this, and now you can see it's flashing down there below what is being proposed. I want that board, so I'm going to click accept over here, and the other accept button, and now my board change has been made. So trust me, if you've got to do a board that's really it's got a lot of curves and a lot of angles to it, it can take a real long period of time to do it in an ECAD tool as opposed to MCAD. So this is a really nice way to push stuff in, especially if MCAD has already initiated the design. So there you go at this point. And then from there, I can go into my project, add my schematic sheets or design my schematic sheets. I've already got this set up. I can push my net list information over and then continue to build off the board that was given to me. And then from that point on, for the placement, we can push this back and forth with our components and our holes, and we can continue to push back and forth until we've got things set up for routing at that point.
And just to reiterate also, as Paul mentioned earlier, we can change the board shape again if we prefer. So we haven't actually locked that down. This could be just a starting point, and it could be modified as needed.
Mm-hmm. The key thing always to remember is that if you understand that part of the printed circuit board aspect where there's placement and there's routing, and if you can get all the placements done initially and then everybody agrees to it and you lock it down, and that means the electrical guys aren't moving anything and the mechanical guys aren't moving anything, then the routing will go relatively smoothly, and then you can get into the manufacturing element of it thereafter. So, well, that's what we wanted to demonstrate for you over here. I'm going to jump back to our slide deck here for a moment. So hopefully you enjoyed what you saw over there, and you're definitely here for a reason. And that reason is because you wanted to see what SolidWorks PCB could do for you. What about us here at 9.Connects? Well, we are a PCB-centric organization, and we've done a lot of things with various tools, but we also look at the entire process itself. And what we have seen out there is that there's a lot of stuff that's being thrown at you, like, oh, there's Internet of Things, and there's artificial intelligence, and there's also mechatronics design. So all these big buzzwords are coming out, and we're already seeing that in a lot of these products, and it's kind of a really interesting time to be in, especially as technology is going to take its next step forward over here. But we also know that at the end of the day, if there's no mechanical aspect to it, then it's just a box that's talking to you. And on the other hand, if it's mechanical but it doesn't know how to do the electrical element of it, well, it's just a box that can just only do its mechanical element of it. So we understand that, and we know a lot of people who work in mechanical, but they need some help on the electrical side, and that's what we're bringing here to the table here. That is why SolidWorks has asked us to be their national VAR when it comes to SolidWorks PCB. That's the only tool we do, and we're nationwide, and it's an exception. They don't normally allow that type of opportunity to a company, but they see what we bring to the table when it comes to the electrical aspect of it. So what do we do? Well, we certainly teach SolidWorks PCB, but we also want to emphasize this. There's a tool called, let's say, training we have called PCB Fundamentals. And the reason I want to bring this to your attention is because anybody who has to do with anything when it comes to printed circuit boards, we want them to take a look at this, because printed circuit boards are not taught in academics. They don't. There's no degree in it. They don't even, the vast majority of schools don't even have a class in it. They have always relegated this to the technicians. But in the last 20 years, printed circuit boards have become so complex and it requires so much of an engineering background that a lot of electrical engineers have had to get involved with it, but they get involved with it after they start working in it, and they make a lot of mistakes because no one's taught them the proper way of putting together a printed circuit board. So whether you're an electrical engineer or a mechanical engineer who's got to do with electrical stuff, or you're a program manager, or you're even a purchaser, even the technicians, anybody who has to touch a printed circuit board, they may want to take a look at this. It's a 3-day class, and we teach the entire process. We don't teach a tool, we teach a process, so that at the end of the day, that when you go through the printed circuit board design, you own the process and it doesn't own you. And of course, there are tools like SolidWorks PCB, because you've got to have a schematic tool, you've got to have a layout tool, you've got to have a library mechanism and capability to support the schematic and the PCB as well. And we are experts in SolidWorks PCB. We also do what we call stealth trainings and one-day trainings. Our stealth trainings are these things like SPICE. So if you're familiar with SPICE, that's a simulation tool for analog. It's also built into SolidWorks PCB, and we can teach that as well, so that we have expertise in that particular aspect of the tool. Or if there's other things in the tool that are kind of like very niche, we can certainly assist with that too. That's what we call them stealth trainings, because there's always an interest in it, but not enough to put a 3-day class together. So if you ask us about it, we can certainly do that. And by the way, we're also pretty good with customizing our trainings as well. We also do one-day trainings. These are online trainings, so if you want a little more information about libraries or more information about the schematic or the PCB, we can do that as well. Services. So some people want us to just do the boards for them, and that's perfectly fine. So if they need us to do the design or the layout, which we call, what we call doing the boards, if they need help with their libraries, there's 150 million components out there. So a lot of components, and so people want some help with those libraries. And again, remember, keep in mind, we've got actually 4 elements of a library. There's the schematic part of that library. So for every component, there's going to be a symbol, there's going to be a footprint, there should be a 3D to it, and then there's what we call intelligent information, stuff that we'd use in order to inform the designer who's looking at it some characteristic information about the part, or more importantly, the bill of materials. So these library component developments can get really complex, and we can assist with that as well. And of course, with circuit simulation as well, depending on what type of simulation that you are doing. We also do things like consulting, and this is what we call our soft things, where if someone's like, I need some help with this, but I don't even know where to begin with it. We've kind of done this. Can you review this? Can you investigate that? And so if it's not something that's well-defined, we do something called consulting, and we have a block of hours that you can use as necessary to get through the project. And what we find quite often is that people don't just want to hand it over to us and have something produced at the end. A lot of times they want to get involved with it because they want to see what we're doing, and we're more than happy to do that. So consulting is really kind of a blend of both training and services. It's again just buying a block of hours and using those hours accordingly, and we can do all these various things, because at the end of the day, none of the things we're listing over here are easy. Even if you have a degree in electrical engineering, a lot of electrical engineers, including myself, really don't know a whole lot about RF or even about power or analog. And high speed is really a new area, where in the past you didn't have to worry about the digital signal. It was always a 1 or a 0. But with high-speed design, we've got to make sure it gets there on time. We've got to make sure the integrity of that signal is there, so it still looks like a 1 or a 0 and not just a bunch of noise. So these are the things that we can consult in. That's what we wanted to show you here. At this point in time, I'd like to open it to any questions. And so we'll take a look at the questions panel here. And if you have one, go ahead and write it on in there. If there's any there, we'll take a look at them. You guys are going to make it too easy for us here. Okay. I don't have any questions there. If someone wants to put one in there, feel free to do so. Otherwise, I'll turn it back over to our host.
All right, I appreciate it. So far, no questions. We'll keep an eye on that till the last minute. But I want to take a moment, of course, to thank everybody who joined us today. Again, if you do have more questions, feel free to reach out to us, either directly to the 9-Dot team or to DesignPoint. Either way, we all work together to serve and support our customers. Guys, great job today. Thank you. I think this partnership's off to a great start. We're really anxious to do more work together and do more webinars. For the folks who joined us today, if you enjoyed learning more about this, we will be hosting more webinars on these topics, so please stay tuned, okay? I don't see any questions, so we'll just wrap it up for this time. Again, thank you guys. Did you have anything else?
No, thank you very much for your time and for your audience. We really appreciate it.
Okay, very good. Thank you, everybody. Bye.
Thank you.